Stan Gibilisco here from a nebula somewhere in an unknown galaxy, in an unknown universe, in an unknown set of universes, in an unknown thought kingdom. Bringing you three types of polar coordinate systems commonly used in mathematics and engineering. So let's cut straight to the chase. Oh, Bill O'Reilly's probably furious at me for that triteness. The first version of polar coordinates is called mathematicians' polar coordinates. All types of polar coordinate systems have two things in common. They have a radius coordinate and they have an angle coordinate. The radius usually indicated as r and the angle as theta. In the case of mathematicians' polar coordinates, the reference axis, the zero axis, zero radian axis, goes off towards the right from the center, like that, east as it were, and then the angle goes counterclockwise, increasing in radians to pi over 2, which is a right angle, to pi, which is a straight angle or 180 degrees, to 3 pi over 2, which is 3/4 of a circle, and back to 0. That is mathematicians' polar coordinates because it is most commonly used in theoretical mathematics. However, in applied mathematics and engineering, you'll often see the radians replaced by degrees for the angle, which still goes counterclockwise from a reference axis pointing off toward the right. 0 degrees, 90, 180, 270. In both cases, the radius coordinate goes out from the center, and these concentric circles represent radius increments. They are almost always a linear scale, that is to say, each increment is equally distant from the next one and represents an equal amount of change in value. Both mathematicians and engineering polar coordinate systems. Also, this is true in the navigator's polar coordinate system, which works a little bit differently. The reference axis goes straight up and points towards either geographic north, in the case of true navigation, or magnetic north, in the case of reference to a magnetic compass, such as a hiker might use. The angle goes clockwise and is usually called alpha, meaning angle, which stands for angle, or azimuth really is the angle, the compass direction, or the navigator's direction, goes clockwise in degrees. 90 corresponds to east, 180 corresponds to south, 270 corresponds to west. So once again, what we have here is the mathematician's system, where the radius goes out from the center and the angle goes counterclockwise from east, as it were, in radians. The applied mathematics and engineering system, where the radians are replaced by degrees, but otherwise the system is essentially the same. And the navigator's system, where we have the azimuth, or direction, starting at north and working its way clockwise, 90, 180, 270, and the R, rather than standing for radius, stands for range, which means distance from the center, which is where you are, where your ship is, or your aircraft is, or your reference point, your robot that you're controlling from some safe haven while you use the robot to blow other people up 10,000 miles away. With that happy note, I will refer you to the book that contains information about these systems and a great deal more. Mastering Technical Mathematics, 3rd edition. This is the Amazon page for that book, a link to which you can find in my website if you go to my Amazon link there. Mastering Technical Mathematics, 3rd edition, with a cover comprising chocolate candies with various mathematical symbols on them, and as usual, you can look inside the book and decide whether you want to purchase it or not. I wish you'd buy it, however, rather than pirating it. Then you get a bound copy with all the glory that a bound paperback book copy has to offer, including this wonderful cover. Stan Gibilisco signing off for now from the nebula in an unnamed galaxy, in an unnamed universe, in an unnamed set of universes, in an unnamed thought kingdom. You name it. How about absurd? How about idiotic? Both of those will work fine for me. Until next time, so long.